Hello everybody, I'm Mavasud and welcome to my course on secure network and communication. Today's topic is network access control. So let's see what we'll cover in this particular topic. It is very important part of establishing the network security is managed network access. Network access determines who can get on a network or what in case of process as well as in case of what level of access that entity will have when they are on a network. Sometimes this is done through perimeter defenses. We built a perimeter defense to control the traffic coming in from outside of our organization, but of course it should be emphasized that in many cases this is also going to be based on internal network segmentation as well. For example, for the perimeter, we may use some type of network access control that establish the gateway at the entrance to our network where we can now enforce security policies. One of the things that's required for this authentication is this really a legitimate user or legitimate process, and this can be done both through the identification and authentication of that user as well as in some cases through node authentication that says you can only connect if you are connected from this well-known device. For example, from a registered IP address. This may be enforced through things like a trusted platform module. For example, then we grant the correct level of authorization, and the correct level of uh, authentication can be different depends on if you are inside in a network on the internal network, or if you are connected within a wired connection or wireless connection. We can set up different level of permission upon the network depending on some of those attributes or other factors. In many cases, we can control access from both a user or from that endpoint device. Is this a endpoint device that itself is trusted? This is especially important in today's world where we have the concept of BYOD, that is bring your own device, or sometimes we call it bring your own disaster, or choose your word, or choose your device. In this area, we need to have some control over who can get on our network because they could be coming from a compromised system. This of course become even more important in today's world of Internet of Things and our various SCADA industrial control system. Many times network access is going to be from outside of our organization, trusted computing base outside of our own of our parameter, outside of area we have direct control. Therefore we need to establish the secure remote access. So if we go next, we are having the next topic, which is talking about the secure control networks access. We know that there is a number of type of remote access that are insecure, unencrypted communication that in some cases might even pass passwords in clear text. We saw this is a very simple network management protocol in earlier version. So very often today the answer to everything tends to be multi-factor authentication. Multi-factor authentication, which makes sure that a person or a device only connect if we establish that through at least two different authentication factor. Yes, you can log in, but we will send you a code on your cell phone that you need to enter to be able to verify that it's really you. This also can work together with things like single sign-on, and we have seen it work together with physical security so that you cannot log into the network or a desktop inside the office unless you have already tabbed into the office. You have to tab in with your ID card in order to be able to enter that immediately. That opens the ability to be able to log in when you got to your desk. We have to make sure that all of these devices that are connecting the trusted. Do we do compliance scanning? Do we do discovery scan to see unauthorized devices that may connect? Is someone trying to connect additional type of portable memory? For example, we have to then also try to ensure that these are correctly configured with things like patching up to date. We put in firewall, and firewall are very good device both at a parameter as well as internally between the system. But firewalls is a generic term that can refer to a number of different technologies. We could have something simple as a patch filter or a router as a first generation firewall. It does very superficial but very good connection. Make sure that we are able to see whether or not those rules are fitted with the policies of the organization. But we also need firewalls that are proxies, the packet inspection, that is stateful firewalls, basically stateful inspection, and we can say that stateful firewall as well, depending on how much money we want to spend and how much risk we are facing. One of the things we often hear is people say, yeah, but don't allow remote desktop protocol, especially if you are connecting from outside of your organization. And this is something we have struggled with now for many years. We had this, of course, even back with some of the product that allow you to go right to your desktop or your PC and would able to able that backdoor access into our system. With all these things, we have to look into what is the best way for us to make the risk of remote access, to make sure this cannot be misused by an unauthorized user. So how can we do that till now? So how can we do that? To do that, we are looking for we are looking at secure remote access. Very often we are going to use VPNs. Now VPNs are always the best, but for many organizations this will they will implement, say, TLS or an IPsec VPN to manage that access. So at least the traffic is encrypted. We of course know as network managers that we have to be careful, because a VPN can push an encrypted tunnel back through our firewall onto our internal network. So we still need to architect or configure our network to make sure that we that uh, that we then terminate the VPN in a place that we can examine the traffic before we allow it further in. Maybe we terminate it even at the extent. One of the things that's so important, of course, always privilege access management. This is to make sure that those users that have privileged access are carefully vetted, reviewed, and we don't grant privileged access to more people than we need to. We manage network administrative access. For example, one of the problem we see in that so many organizations today are connecting business to business, enterprise to enterprise, and this is an tremendous business benefit. The purpose that when a store runs uh, runs out of the product, an automated process can go and order new inventory from a supplier without people having to it involved and create additional roadblock or delay in that process. But when I establish those trusted connection between organization, we have to watch that those do not become a backdoor or a point of entry as a change exploit into our organization. We need to monitor and correctly provide network segmentation in place. We have third party connectivity. This is especially important in the world of building management system. For example, where vendor may need to access to check whether or not. Building management system, where a vendor may need access to check whether or not the air condition is working well. What control do I put in place so that the access granted to the vendor is not able to use to grant access to other part of your network? This is of course where we need to provide things like whitelisting. We also have to establish remote voice, because we know that a lot of our communication today is on voice over internet protocol. Not all, but we see this built into many of our application. Many of the applications automatically will encrypt traffic from end to end right at the application level. But we can also do this using when using well. We used to call this as a secure telephonic unit, or STUs. Actually, a hardware device at a physical layer that will establish a secure voice connection even over an analog line. In that case, we can secure the phones themselves, where the encryption capability is built into the hardware of a phone. And we have seen that many types of even handheld unit have that capability to ensure we have secured voice communication. One of the things we do see in some cases is that certain phone calls can only be made if you are in a secure room. A secure room is one usually without window, that is wrapped in a Faraday cage, so that is no way for any of the signal to escape out of that room into another area where it could be monitored by someone else. Something we often refer to in the word of tempest, so that you would have a phone in that room. Obviously not wireless, because wireless won't work in room like that, but we could have a phone that called them be used to establish secure connection to person at the other end. We need secure data communication, and visa with ISO standard 7498, it is actually possible to build encryption into every layer of OSI stack. We know that we encrypt the lower layers, say this is hardware based device at a physical layer. That is often more efficient, a little faster stream based encryption, and so on. And it encrypts all the traffic over the physical medium. But we often need granularity. We need the ability to ensure that some things are more protected than others. And granularity is precious too, which I can manage control like that. So encrypting at a higher level can provide more device to device type of security. So this is what we are having we are supposed to have in today's session. Thank you for joining me. In the next session we will be discussing by example of an attack. So thank you for joining me.